So the purpose of this project is to learn how to use an ultrasonic sensor and how it works when it's connected into the circuit and into an Arduino. The ultrasonic sensor is a device that its function is to measure the distance of an object by using ultrasonic wave sounds as a way of measurement. These waves cannot be heard as they travel faster than the speed of audible sound. Once the sound wave transmission is being received, it measures the time it took from the transmitter to the receiver. The transmitter component is when the ultrasonic sensor emits the sound, and then the receiver component is when the encounter receives the sound after reaching its target. The objective of this project is to learn how to use and understand the ultrasonic sensor, how it works when being connected on the breadboard and into an Arduino, while also having a code measuring the distances for the ultrasonic sensor. We will learn how to connect the code and make it work in real time. We will also learn how to make the ultrasonic sensor work and how it is used in real life applications. The ultrasonic sensor role in automation is to sense objects on different distances specified by the user. Its application will be determined by the user. It can either function to detect any kind of movement, or one can use it to give the distance between the device and the object detected. How the ultrasonic sensor works. The ultrasonic sensor works by emitting ultrasonic waves by sending them through the transmitter to the detected object and going back to a receiver from the detected object and converting them into an electrical signal. To convert what was read into distance, the equation that must be used is distance equals to velocity times time over 2. It's going to be equal to the result you give it in distance in meter over seconds.
Hi, so the materials that we're going to be using for arranging the circuit, it's a ultrasonic sensor, your cables, 3 LEDs, a buzzer, your breadboard, and your Arduino. Once we have already our circuit assembled in our breadboard and the code downloaded into the Arduino, we will then proceed to test our circuit. The object we're going to be using is this. As you can see, if I put it at a distance of 30 or less, only the green LED will turn on, as you can see. And then if I start bringing the object closer, the yellow LED will turn on because it's at a distance of 20 or less. And if I start bringing closer, then we have our red LED turn on because it's at a distance of 10 or less. Then we'll be bringing it a little bit closer. Once we hear that pitching sound, it's because our object is at a distance of 7 or less. And as we start bringing it closer, you can still hear the sound. As you can see here, we show the results of the taking distances of the ultrasonic sensor. Thank you.
The real-life applications of the ultrasonic sensor. This has many infinite applications, as we use it in many conventional house objects to industry machine levels to robotics. At a house level, we can find it in smart alarm automation systems, where they're used as motion sensors. When the sensor detects a movement when the place is supposed to be emptied, it will then trigger an alarm. This can be also installed in industries, or anywhere in a small alarm automation system can be installed, so not only at houses, stores, or in industries. Another role of the ultrasonic sensor in automation is on submarines to measure the depth of the ocean and to detect any object being an animal, a boat, another submarine, or ocean ground. This helps the submarine to guide themselves into the dark ocean. Vehicles nowadays can contain ultrasonic sensors whether it's at the back of it or at the front, or even both. When the ultrasonic sensor is at the back of the car, it's mainly used to detect any kind of movement behind the car and the distance from it. Depending how close you are from the object, the buzzer will then ring, warning the user that it's too close to hitting an object. In newer vehicles, the ultrasonic sensor can be in front of which which will sense a car that's in front, and it's extremely close, the car will stop, impeding a collision. Also, it will regulate the car's speed to also avoid a future collision.